It looks like our universe keeps repeating the same mysterious pattern. Our Earth revolves around a star that has shaped the entire solar system. And the solar system, just like other star systems, is also orbiting a supermassive black hole at the center of the Milky Way. It turns out that galaxies must swarm around something even more tremendous. I'm talking about the very first giant black hole at the center of the universe. But where could this mysterious object be hiding? Our search relies on the assumption that black holes are galactic nuclei, but they're not. Most of them are just randomly flying through space. In 1964, astronomers discovered the first black hole in history, Cygnus X1. It's more than 20 times the mass of our Sun, and it formed from a progenitor star that collapsed and shrunk to just 44 kilometers in diameter. And in the Milky Way alone, there are over 100 million such black holes. And although Sagittarius A star at the center of our galaxy stands out among them with an enormous bulk of 4 million solar masses, it's actually negligible compared to the Milky Way as a whole. And while in the solar system, the Sun itself accounts for more than 99% of the solar system's mass, Sagittarius A star contains only 0.2% of the Milky Way's mass. That's because it wasn't a supermassive black hole that gathered a galaxy around itself. It was the other way around. It's just that in the central region of the Milky Way, the density of stars is 2.5 million times greater than around the Sun. Over time, these stars exploded, collided with each other, and eventually formed a supermassive black hole in the center. So, considering Sagittarius A star and similar objects as galactic nuclei is a big misperception. Then the idea that a black hole is the universe's core also seems doubtful. But we sin against common sense much more just by saying the words black hole. The name black holes is so inappropriate for these objects that even 18th century scientists would consider it foolish. In 1774, an English country parson, John Mitchell, reflecting on Newton's theory of universal gravitation, made a discovery far ahead of his time. He realized that there could be stars so massive that not even light could escape their pull. And since they would be invisible in the night sky, Mitchell called them dark stars. And that's 150 years before Einstein published the equations for his general theory of relativity. And using those equations, 20th century scientists calculated the exact parameters of real dark stars. But even then, it never occurred to anyone to call them black holes. According to Einstein's theory, such objects would be a trap not only for light, but also for time itself, which infinitely slows down near them. Therefore, they were dubbed frozen stars. So, how did the widely accepted term come into being? There's a legend among scientists that back in the 60s, the phrase black hole was shouted out by a first-year student at a lecture, and then journalists heard about it and the expression became fixed. But hey, it's hard to come up with a more incongruous name. After all, these objects are filled with enormous masses of compressed matter, which is the complete opposite of an empty hole. And besides, even though they swallow all light, black holes are not black at all in the night sky. That's because most of them suck in matter with such force that it turns into a hot accretion disk, and its glow can extend into the depths of space for thousands of light years. As a result, quasars with supermassive black holes are the brightest objects in the universe. Their glow is 1,000 times stronger than that of a typical galaxy. But if supermassive black holes are so bright, why can't we find the very first of them? I mean, they must be even bigger and brighter. And among them, there might be the black hole at the center of the universe. But it's not that simple. The problem is that most likely there are no first black holes in the universe, although at first glance, some of them fit that description very well. The brightness of this quasar is 36 trillion times stronger than that of our Sun, and the mass reaches 1.5 billion solar masses. And yet, due to the enormous distance of 13 billion light-years, we see this monster as it was only 700 million years after the beginning of the universe itself. Well, can it turn out to be the very first black hole at its center? After all calculations show that this quasar couldn't have formed from a star and couldn't have gained so much mass in such a short time. However, our scientific theories claim that's not what we're looking for. In 1974, Stephen Hawking proposed the existence of the so-called primordial black holes. They spontaneously emerged from the overdense regions of space immediately after the Big Bang, bypassing the star stage. But such objects shouldn't glow like quasars because near them, there could have been no matter for a bright disk. In addition, because of the rapid expansion of the universe in the first moments, primordial black holes couldn't have become supermassive. The smallest of them would have disappeared by now due to Hawking radiation. So, why do we find giant, ancient quasars? They might very well prove to be several first-generation black holes that just happen to be next to each other and merge together. As a result, primordial black holes have long been swallowed up by other ones, and we'll never find them. But maybe it's at the center of the universe that we can still find that single chief black hole that started it all. The problem is that, in fact, our universe has no center, even though we might feel otherwise because of the very name of the Big Bang Theory. When we look at a massive explosion on Earth, it really has a center. But the universe, in the first moments after the Big Bang, expanded quite differently. It's like we're on the surface of an inflating balloon, and you won't be able to find the center where the expansion started because it's happening everywhere, in all directions, simultaneously. That's why, if you look at space through the eye of a reasonably powerful telescope like the James Webb, you can theoretically see the beginning of our universe in absolutely any direction. But wait, according to the Big Bang Theory, today's vast universe was preceded by a single superdense point that contained all matter. Isn't that the same as a black hole? Many scientists have long noticed this striking similarity and put forward an incredible theory that the emerging new universe is just like ours, may be nested inside old black holes. In this case, space is full of millions of seeds of new worlds flying everywhere. And then it's obvious why we can't find the first black hole at the center of the universe, because we're actually inside this black hole, and we'll never be able to get out to see it. But the paradoxical nature of black holes led astrophysicists to elaborate another crazy theory. According to the holographic principle, our universe can be just a three-dimensional projection, that is, a hologram on a two-dimensional surface of a giant black hole. And as it fills literally the entire universe, look around. Congratulations, you just found the first and only black hole at the very center of the universe.